Hi, in this brief tutorial video, I'll be showing you how to use the Asteroid Institute's Precovery service to search archival data for possible historical detections of asteroids. To start, go to b612.ai. At the top, mouse over Atom Platform and click on Precovery Service. This brings up the main form to launch a precovery search. These searches scan the Asteroid Institute's hosted datasets for any observations that line up with an orbital trajectory. You can specify the trajectory with Keplerian, Cartesian, or cometary orbital parameters. If you've computed an orbit yourself, you can type these parameters into the fields. For an already known object, it's much easier to use the Jet Propulsion Laboratory's orbital parameter estimates. To do that, type the name of the object into the Search JPL small body database field. The name can be an asteroid name, like Apophis, or a number, like 99942, or a minor planet center provisional designation, like 2022 SF289. Let's search for that last one, 2022 SF289. I type it into the search box, click search, and the orbital parameters are populated. Now I can select the data sets to search. I'll leave the defaults, which search the Morlab source catalog, data release 2, and the Zwicky Transient Facilities archive. I can also set a few more search parameters at the top. The Start MJD and End MJD fields set the time boundaries in modified Julian date format for our query. Only observations inside of this time range will be considered, and the defaults are to search all data. The Radius field sets our tolerance in the search. Any observations within the radius of the orbit will be suggested as precovery candidates in the final result set. I'll leave this at 5 arcseconds. We're ready to launch the precovery search, so I click Submit at the bottom of the page. Now on a page that will wait for results. Most precovery queries take between 2 and 10 minutes to complete. The time to execute depends on the time range covered, the number of datasets searched, the number of hits, and the number of users currently executing precovery queries. All requests are queued, so if others are using the service heavily, you might have to wait. Once the query is completed, you'll get a results page. You can refresh manually, or you can just wait. The page will automatically refresh once results are available. In this case, I've previously done a search for 2022 SF289, so let's look at the results now. This page shows that the job has succeeded. At the top, we have a bit of information on the request that was submitted. It looks on the right like we have 8 matches. In this case, all are novel detections, which are not present in the Minor Planet Center's database, but this is not a certainty. Currently, our tool will present any detections that are found, whether or not they've been reported previously. Next are cutouts. These are portions of the original calibrated imaging data centered around detections that we believe match the input orbital parameters. Each cutout is from a distinct image, with a timestamp that you can see in the header. The green ellipse is centered on the detection in the source catalog. The green crosshair is centered on the predicted position of the object based on the input orbital parameters. And the blue arrow points in the direction of the predicted velocity of the object, and it's scaled proportionally to the magnitude of the predicted velocity. In this case, all of these cutouts look pretty good, but look at them carefully to identify outliers. Further down, we can see a table of all of the matches for the precovery query, with lots of data from the source catalogs, as well as predicted estimates based on the input orbital parameters. These can be downloaded as a CSV for later analysis. In addition, the precovery results list misses. Each miss corresponds to an image in our archive which might have overlapped with the object's trajectory through space, but doesn't appear to have a detection at the predicted location. You can expect to have many misses for any precovery query. The object might not be present simply because it's too dim to detect. Most small bodies are only visible for a relatively small fraction of their orbit. This tool is excellent for doing searches for just small numbers of objects. But if you're interested in doing larger bulk searches, get in touch. We have bulk systems capable of searching for thousands of objects concurrently and can work with you and your team to launch those searches and help analyze the results. Thanks for watching, and let us know if you have any questions or feedback. We hope this tool is helpful and are planning to add more datasets, features, and capabilities in the coming months.